This video is going to go through a number of conceptual questions. These questions are going to be specifically related to the electric field and specifically dealing with point charges as well. So as usual, please pause, answer the question on your own, and then watch the solution. Here is the first question. So the correct answer is A. If you were watching my videos, I didn't specifically say a proton, but we did define the test charge. Our author defined the probe charge, meaning the same thing, as a positive charge. So the proton is the positive charge in this case. Here's our next question. So the correct answer is A. There's a couple ways to look at this. We know the electric field equation for a point charge depends upon the charge itself and how far away, and point A is closer since distance is in the denominator. Closer means a bigger field. We can also tell just by the picture and consider the distance between the lines. The farther the distance between the lines, the weaker the field is, the closer, the stronger. So both ways work in explaining the correct answer as being A. Our next question. Correct answer here is B. So just to mention, this dot represents just a location nearby this charge. So there's no charge here. No charge at this location. But we know the negative charge is influencing all the space around it. It would exert a force on a charge that was there at this point. Since the definition of the electric field is based off of a test charge being positive, we know if we put a positive charge here that it would be attracted to this negative charge in the figure. And that gives us B as the answer. So one general rule with electric fields is electric field lines will always point away from positive charges and will always point towards negative charges. So B is our correct answer. We still have a few more questions, so here is the next one. The correct answer here is B. So the positive charge would be creating an electric field that points away from it. The negative charge would be creating an electric field that points towards it, and that field will be stronger. In fact, it's going to be 4 times stronger. And that's because electric field is also an inverse square law. The distance squared is what matters the most. So when we add these two vectors together, we get a resulting vector representing the net electric field there, pointing in direction represented by B. Okay, our next question. What do you think here? Correct answer here is D. This dot appears to be directly in the middle between the two charges, of course offset upwards. So the positive charge would be creating its own field that points away. The negative charge will point its field pointing directly towards it. Those would have the same magnitude and angle. So the y components would cancel and the x components would add together to give us D. You can show it too if you remember adding vectors head to tail or tip to tail. Okay, here is our next question. Now the point they're referring to is this black oval. I'm not sure why it's oval, but there you go. Well, the correct answer here is going to be B. If I draw these again, so I have a better place to draw a picture. So our point right here, this top Q is going to create an electric field that points straight down, because that is the direction that points away from it. This second Q is going to create an electric field that points directly to the left, because that's away from it. 2Q is going to create an electric field that's twice as big as either E1 and E2. It points away from it because it's a positive charge. When we add these two together, since they're along the same line, we end up still with E1 pointing down. Because this 2Q creates twice the electric field, we essentially get the same magnitude as E1, but pointed to the right. So when we add these together, the result will be exactly at a 45-degree angle. Because these two, the vertical and the horizontal, will have the same magnitude. Because they were the same charges at the same distances. So B is correct. All right, one last question. The correct answer here is C. So two protons, both of them will be creating electric fields that point away in all directions. That means in the exact center between them, at a point exactly in the middle, there has to be no electric field at that point. They're going to create the same magnitude of electric field, but they will be in opposite directions. Thus, they will cancel. That gets rid of A and B for us pretty quickly, because the figures for C and D show us no field, no lines going through that point. The determining factor here is remembering that electric field lines point away from positive charges. D is showing some of the lines pointing towards the positive charge, which is why D cannot be the correct answer. So C shows us both a 0 in the middle, and it shows us arrows pointing away from both charges.